So, everything you always wanted to know about quadratic functions, what we're going to do is take a bunch of quadratic functions, right, the equation of them, and from the equation, figure out the characteristics, right? Like, which way does it open? Vertical stretch factor, does that make it narrower or wider than the graph of y equals x squared? Where's the vertex? Let's do a little sketch of the graph. What's the equation of the axis of symmetry, the domain, the range? Does it have a max or a min? And the value of x where it occurs, and the x-intercept or intercepts, and the y-intercept, which will be 1. So, negative 2x squared plus 14, up or down? Down. How do you know? Okay, negative value in front of the x. Does it have a vertical stretch factor? 2. And it is 2. Is it narrower or wider than the graph of y equals x squared?
Narrower.
Narrower, right? So any stretch factor greater than 1. Where is its vertex?
0, 14.
0, 14. How do you know? Okay, y-intercept's 14, but why is the vertex there? So is there any left or right?
No.
That's how you know it's 0, right? There's no left or right. The x, this moves right 3, right? This does not go left or right, so the x coordinate 0 and up 14. Okay, what does it look like? So we know it opens down, we know the vertex is at 0, 14. So the equation of the axis of symmetry is?
X equals 0.
X equals 0, right? X is equal to the x coordinate of the vertex. The domain is? Real, so you can just fill that column in, right? Every polynomial function has a domain of all real numbers. The range is?
Y is less than or equal to 14.
Yeah, so y is less than or equal to 14. Does it have a maximum or minimum value?
Yeah.
Yeah, okay, good. I think they all do. But could you be more specific?
Has a maximum Y value.
Yeah, so it's maximum y value of 14 when?
X equals 0.
Max y of when x equals 0, right? And again, it's all just related to the vertex, right? As far as axis of symmetry, as far as max or min, etc., etc. Let's do the y-intercept first, because that's easy. What's y-intercept?
14.
14. What are the x-intercepts? Pause. So the x-intercepts aren't kind of easy, obvious stuff, right? We need to solve this, right? So when do the x-intercepts occur? When y equals 0, right? So we're going to have to go 0 is negative 2x squared plus 14. So negative 14, right, move the 14 over, is equal to negative 2x squared. So x squared, just flipping sides, is equal to 7, and x will be plus or minus the square root of 7. There's your x-intercept. Root 7, negative root 7. Okay, sorry, I kind of had to squish that in there, right? Okay, any questions on the first one? Nope, give you a sec, copy down. So we want to find the y-intercepts. If it's not obvious, right? I mean, some of them are obvious, right? This is obviously whatever. Then you have to set y equal to 0, and you have to solve for x. Right? Could involve factoring. Could involve quadratic formula. In this case, no, you don't need the quadratic formula. Right? There's no b value, so it just kind of works out. Okay, next one. Up or down? Up. Vertical stretch factor. None or 1. Actually, yeah, let's write none. There is no vertical stretch factor. None. Narrower or wider? It's the same. Where's the vertex? 3, 0, right? What's that tell us, right? Moved right 3. No up or down. So 3, 0. Vertex is at 0, 0, moves to the right 3. So 3, 0. Okay, opens up. Vertex is at 3, 0. Equation of the axis of symmetry. X equals 3. Domain. Range. You look at the sketch. Yeah, y is greater than or equal to 0. Max or min? Minimum y. I suppose really should say minimum y value, right? Value. Minimum y value of 0 when x equals 3. X-intercepts. 3? Yeah. It's just one intercept, right? And y-intercept? Y-intercept. So we're going to have to figure that one out, eh? How do you get the y-intercept? 9. Okay. Just set x to 0, right? 0 minus 3 is negative 3 squared is 9. Okay, good. I'm going to rely on you. If it's not good, you tell me, hey, wait, how'd you get that? Or, hey, that's wrong. X plus 2 quantity squared minus 16 opens up. Hang on, I gotta leave at least one there so I know. Something that had none before. Oh, the stretch factor? None. Not 0. I don't know what 0 would do, like take it down to a point. Width? Same. Vertex? Okay, so negative 2, negative 16, right? So 2 to the left, down 16. So 2 to the left, negative 2, down 16. So what's it look like? Negative 2, negative 16. Axis symmetry. Range. I heard somebody say it. Max or min? I'm kind of thinking, to myself as we're doing it, is that column's really sort of redundant, right? But if that's all you were asked to do, right, was just to say, is there a maximum or minimum value, and what is it, and where does it occur, then, so sort of think of that thing as that could be asked of me separately, not, come on, it's obvious, right? It's right there. There's the vertex. You've got it. But y-intercept, let's do that first. Negatives. No. Can't be negative 16. That's the minimum, and this thing has moved over, so it's not negative 16. How do you get the y-intercept?
This one, x was 0.
Yeah, x was 0. So 2 squared is 4 minus 16 is negative 12. Okay, and the x-intercepts. Let's write this in here. Y equals 0 minus 2 squared, 6. Minus 6 or 2. How'd you get those?
Some calculation.
Y equals 0.
Okay, y is equal to 0. So then we'll move the 16 over, square root both sides. Okay, so here let's move these up. Okay, so let's go 0 equals x plus 2 quantity squared minus 16. Okay, so we've set y to 0. So that means that x plus 2 squared is equal to 16. Right. You move it over, then you flip sides. So it becomes 16 equals x plus 2 squared, and then you just flip it. So x plus 2 is equal to plus or minus 4. So x is negative 2 plus or minus 4. Negative 2 minus 4 is, or negative 2 plus negative 4 is negative 6. And negative 2 minus negative 4 is positive 2. Now I can kind of see one other way to do this, which relies on the fact that we know the shape of the parabola, right? We know that if you go over 1, you go up 1. If you go over 2, you go up 4. If I go over 4, how far up do I go? What's 4 squared? 16. There's no vertical stretch, right? So I say, hey, if you're down at negative 16 and you go up 16 units, where are you going to be? You're going to be at 0. So if I go 4 units over here, I'm going to be at positive 2. And if I go 4 units over here, I'm going to be at negative 6. Okay? So that's another way. It's not going to work for all of them. It just happens this time, hey, it's down by a square of x, right? So it's down, moved down 16 units. And I can go up 16 simply by moving 4 units over, since there's no vertical stretch. Right? So I was just kind of looking at it this morning and said, hey, that's another way to do it, right? I mean, you could do it algebraically. And you can do it on your graphic calculator. Okay, next one. Which way? Up. Vertical stretch.
0.5.
Let's go with 1/2. Because a half is exactly. What are you going to say if it's 1/3? You're not going to say 0.3 or 0.33 or 0. Yeah. So if it, fractions are always good because fractions are exact, right? Even when you can get an exact decimal, so 2/5. Okay, yeah, that's 0.4, but leave it as 2/5. So when you've got 1/6, you don't try and make a decimal out of it. Narrower or wider? Wider. Vertex. 5, 2. Okay, so I've got to get a 5, 2 opening up. So 5, 2 opening wider. At least the x-intercepts are easy. No, I guess we could label these. Well, that's 0. What was this? 2 and negative 6. X symmetry?
X equals 5.
5. Range? Did somebody say less than or equal to? I don't know. The way I drew it, I think it's got to be greater than or equal to. Okay. Yeah, that one. So it's got a what? Minimum y value of 2 when? X-intercepts? None. Easy, right? Opens up. So be careful. Don't write 0, right? That would be if I asked you how many x-intercepts are there. And RTQ, right? Read the question, because you might be asked how many x-intercepts there are, not what is it, and you're sitting there going, oh, there's no x-intercepts. Okay, but I want to know what they are, and you got to say there's none, right? Not 0. 0 is a number. 0 says that that's what the x-intercept is. None says there aren't any. And the y-intercept? What do we got? 14.5. Good with that? 0 in, 0 plus, what is it? 0 minus 5 is negative 5, squared is 25, half of that is 12.5, plus 2 is 14.5. Okay, good. I don't need to write that down. I don't want to write that down. Up or down?
Down.
Vertical stretch? Narrower or wider? Vertex? -1, 18, right? Left one? Sketch. -1, 18. Opens down and is narrower. Axis of symmetry, equation thereof. -1. Okay, when you do it, make sure you write it as an equation, right? X equals, don't just write down -1, right? Because that will result in -1 marks. No, 0 marks. Actually, I will consider actually taking a mark off if you leave a multiple choice question blank. Right, so I won't give you 0, I'll give you -1. Which says,
We just forgot that button.
well, sucks to be you. Don't do it again. No, I really would like to train you to always answer a multiple choice question. Like, take your best guess, because on the diploma exam, if you leave it blank, what are you going to get? 0, right? They won't take 1 off. But I'm going to make sure you don't leave it blank. You know, you got to at least fill something in. Okay. I don't know if I will or not. I probably won't. I'm softy, but you know, keep that in mind. Right. Do not leave multiple choice. It's okay to leave numeric response blank. I mean, there's like 12,000 possible answers. So guessing, maybe not. But sometimes, you know, numeric response are arrange these in order from narrowest to widest or something. Right? Give you 4 equations and say arrange these in order from the narrowest to the widest. You know, equation 1, equation 2, equation 3, equation 4, and the answer could be like 3, 2, 1, 4. That's one that you can kind of guess at, even if you're not entirely sure, because there's only 4 possible numbers, and they each go in one spot, right? So that's only 24 possible answers, not 12,000. But I digress. X belongs to the reals, and Y? Less than or equal to 18, so it has a maximum Y value of 18. When? And what's the easiest? Y-intercept's probably easiest, right? What's the Y-intercept? 16. What are the X-intercepts? 2 and -4. Okay. Anybody want to see that worked out? Okay. So what are we going to do? We're going to go 0 is equal to -2 x plus 1 squared and plus 18. We're going to that just says this with a 0 in there, okay? I'll write bigger now. So that becomes -18 is -2 times x plus, what is it, 1 squared. Okay, so we move the 18 over. Divide both sides by -2, so it becomes 9 is equal to x plus 1 squared. Square root both sides, and the number one surprise of the day is not that, but the...
I had a doctor's appointment. I have legitimate excuses.
Sure. So the other ones were illegitimate then, right? Okay. So, big thing when you square root both sides is you don't look at 9 and say square root of 9 is 3. You say the square root of 9 is plus or minus 3, right? Because you have to get 2 roots. You know there's 2 solutions there, right? You can see there are 2 x-intercepts. So you just write a 3 down there. It's going to give you 1. So plus or minus 3 is equal to x plus 1. And I leave the rest to your imagination, right? No room to fit, but x will equal -1 plus or minus 3. -1 minus 3 is -4. -1 plus 3 is whatever it is. Now, also, it's vertically stretched by a factor of 2, and I need to go down 18, right? Now, what's going to go down 18? How far from the vertex would I move to go down 18 given that vertical stretch by a factor of 2? 3. I'd move 3 units, right? Because 3 squared is 9, but it's vertically stretched by 2, so that will take me down 18, which means if I move 3 units either side of the vertex, that's where they're going to be. right? So -1, 3 units to the left gets you -4. -1, 3 units to the right gets you +2. Okay? Make sense? This one just happened to work out that way too. I mean, I don't know if the last one will. Yeah, I don't. It could be a coincidence, but it might not be. Up or down? Vertical stretch. And we want to sketch that. So it opens up. It's at 7, -24. Okay. This one won't work that way, right? Because with a vertical stretch of 3 to go up 24 units, I'd have to be 8, and 8 would actually be square root of 8 units. Which means these y-intercepts won't be nice. X equals? Okay. Good. Y equals? Oh, sorry. Greater than or equal to? All right, that's not. Yeah. That's, okay, so 7, -24. What? Minimum. I wrote it differently this time. Y equals -24 when x equals 7. Y-intercept, that's got to be easier. 147 minus 24, right? 123. X-intercept.
7 minus 8.
Do we know the quadratic formula? Is that in 10C? I forget. No? Probably not. Quadratic formula, ring any bells? Nope. Okay. I don't know, I just taught 10C last semester. I can't remember what's in there. So this one you probably do on your graphing calculator for now. Right? So now you can give me decimals because this is not easy. What we get? Yeah, we get 8. Yeah, and I get where you're a little ahead of the rest of us, so it's fine. So let me give it to you. It's 4.17 and 9.83. Okay. All right, so what does this tell us, right? It tells us if we are given the equation, we can figure out a lot of the different characteristics, right? We can figure out the direction of opening, if it's vertically stretched, does that make it narrower or wider than y equals x squared? Where's the vertex? What's the axis of symmetry? The domain and the range, does it have a max or min value? What is it and where does it occur? What are the x-intercepts? Most of you can figure out. And what's the y-intercept? Yes, we can always figure that out. Make a sketch of each function and state the number of x-intercepts. Now, sketches don't have to be totally accurate, but they shouldn't be out to lunch, right? Like if you say the vertex is at negative this, negative that, you can't draw it up here somewhere, okay? It's got to be, vertexes need to be about where they are, okay? Or at least reasonable. And state the number of x-intercepts. Okay. So, where's the vertex? -1, 3. So we're going to go here and here. And which way do we open? And we are narrower or wider? So we're pretty narrow. So the number, how many x-intercepts? 0 x-intercepts. Okay, which is a whole lot different than the x-intercept is 0. Right? So this is number of, right? You do not want to get questions wrong on the test because it asks for the number of and you gave me what they are. X minus 7, y equals this. Okay, where's the vertex? -7, 0. And which way does it open? And how many x-intercepts? One x-intercept. Y equals -2, x minus 3, quantity squared plus 6. Where's the vertex? 3, 6. 3, 6. Which way does it open? How many x-intercepts? 2. Did you need to make a sketch? No. Is it helpful to make a sketch? Yeah, you know, you're going to have time on these tests, so really, you know, writing more stuff down is better than writing less stuff down. Okay. I mean, it helps you to answer it. This question might just be state the number of x-intercepts, right? Not asking you to write it, make a sketch or not, but you know, you might decide, let me draw this, let me just see where it is, right? As opposed to, I mean, on these, you really just say, where's the vertex? So that it's above the x-axis and the thing opens up, no x-intercepts. It's on the x-axis, 1 x-intercept. It's above the x-intercept, but it opens down. That'll give me 2. State the conditions for A and Q such that the function y equals a x minus p quantity squared plus q has no x-intercepts. Okay, so let's start with a is greater than 0, which will make it what? Positive? Okay, so no x-intercepts. If a is greater than 0, then what can we say about q? Okay, so if a is greater than 0, saying if it opens up, then to have no x-intercepts, it's got to be moved up, right? Okay. So a is greater than 0, let's just write it away, and q is greater than 0, or a is less than 0, and q is also less than 0. So we're going to open down, but we're going to move it down. There will be no x-intercepts. And q is less than 0. Okay, if I want one x-intercept, well, a can be actually anything, but it's all about q, right? Q equals 0. So a cannot be 0, and q must be 0. Right? If a is 0, it's no longer a quadratic. It's just a constant function, right? It just becomes y equals q. That's not a quadratic, and we want a quadratic. So a can't be 0, right? So it can open up or down. It just isn't moved up or down. Then you have one x-intercept. And two x-intercepts? So it's just going to kind of be the opposite of the no x-intercepts, right? If a is greater than 0, if it opens up, then to have two x-intercepts, you're going to have to pull it down, and that'll drag it down, and you'll have two x-intercepts. Or, if a is less than 0, then q is greater than 0. Okay, questions? Think about, if you want, draw yourself little sketches for each one. Right? So we could do this. Opens up and up. Right? So that's a is greater than 0, q is greater than 0. A is less than 0, q is less than 0. Q is equal to 0. Okay. Doesn't matter what a is in that one, right? Whether it opens up or down. And then lastly, yeah, what do we got? A is greater than 0. And a is less than 0. Okay. So it doesn't hurt if you want to sketch it out. It helps you, visualize it, right? You get a bunch of questions on this. Right? You're going to see that stuff. You're going to say, okay, yeah, got what it means. Definition, image point, the point that results after transformations have been applied to a point on the original graph. So in other words, where does it end up? like if the vertex is at 0, 0, it's going to end up somewhere. Where does it end up? That's its image point, right? And doing this kind of stuff is really going to help for 30-1, because there's a ton of transformations in 30-1. All right, so the graph of y equals x squared was transformed to the graph of y equals -1/4 x plus 1 quantity squared plus 6. Okay, now remember, what's the order of transformation? Get up in the morning, first thing you do is stretch, then you walk to the mirror, and reflection, and then translation. That's all it's like. You come to Spanish class, you translate stuff. So, number 1, right, in order. So number 1, we have a vertical stretch by a factor of how much? -1/4. And the stretch occurs about the x-axis. Okay, so let's throw that in as well. So what kind of stretch? Vertical stretch, right? That's all we know right now. Okay, next year you'll start doing horizontal stretches. But for now, all we know is it's a vertical stretch by a factor of, the negative does not enter into this, not into number 1, right? So if you write a vertical stretch by a factor of -1/4, it'll be a big X through that. Okay, so it's a vertical stretch by a factor of 1/4, and you are stretching it about the x-axis. Number 2, what's the second one? A reflection in the x-axis. So now the negative comes in. Number 3. Translation. Which one do you want to do first? Horizontal. I always do horizontal then vertical. Because that's what you come to first. You're going from left to right, you come to the horizontal first. So it's an HT. Which way?
Left.
How much?
Or even.
Okay. So you need 3 things, right? HT or VT, right, for translation. Which way? Left, right, up, down for vertical. And how much? Okay, and the last one is?
Translation, 6 units up.
Yeah. I like to say up 6, but you can say 6 up. All right. It is really, let's say really a dozen times important that you be able to do that, right? That you can look at something like that. So all that's missing from 30-1 is 2 other possible things that could happen, okay? Actually, there's 3. So there's just like 3 new things you're going to learn for transformations next year. You're not responsible for them this year, but it's vitally important that you can look at the equation and write that down in words, okay? And you should do that. Every time if I'm asked to do translation of that image point, I'm going to start off by describing the transformations, right? Because I need to know what's happening. Now, it says the point, -2, 4, lies on the graph of y equals x squared. Determine its image point after the translations. Okay, so let's say we start. Here's the original point. The original point is -2, 4. So I was going to copy that down. Okay, now I'm going to apply these one at a time. Okay, so I'm going to do a vertical stretch by a factor of 1/4. So Vs by 1/4. So what's the new point? What does the vertical stretch affect? The x or the y or both? It affects the y. What's it going to do to the y? Reduce it. Okay, so what's y going to be? 1. So what do? We take 1/4 of the y value. Right? That's what we're doing. We're doing a vertical stretch by a factor of 1/4. All right, fine. You were at 4, now you're at 1. Okay, next, we're going to do reflection in the x-axis. So what's my new point? Yeah, so if we're reflecting the x-axis, think about it. So you're here, -2, 1. Here's the x-axis. You got to flip down under, right? So we're going to take the y value and replace it with a negative. So it's -2, -1. Okay, next we're going to go left 1, ht left 1. So where do we end up? -3, -1, right? And then we're going to go vertical translation up 6. So finally we are at -3, 5. Okay, so looking at that, we kind of see there's a little bit of a pattern, or there's something going on there. And what is it? It's that the vertical stretch only affects the y value, right? The reflection in the x-axis only affects the y value. So what's the only thing in there that affected the x value? The horizontal translation left 1. That's the only thing that's going to affect the x. Okay. Otherwise, all three of the others only affect the y value. The point 39 lies on the graph, determine its image point after the transformations. Leave your answers, so do this, you're on your own now. Do this, leave your answer as fractions. Okay, so don't give me decimals, right? Just do fractions. Okay, so just start. You just duplicate this. This is exactly what you're going to write. This is exactly the same, and these are going to be different because you're doing a different point. Okay, and when you're done, look up. We're going to fill in little bits every, few seconds. Stand in front of it.
Really?
Okay, so -9 quarters plus 6 is -9 quarters plus 24 quarters is 15 quarters. Bless you, which is $3.75.
Wait, what?
15 quarters, $3.75. Okay. No decimals though, right? We like fractions. We don't like decimals. Unless it's numeric response and it says rounded to the nearest whatever, then we're okay with decimals. Bless you. Okay, questions? Right, all you do, right? I mean, the describe the transformations is really the most important thing, right? You need to be able to take that equation, to look at, and then to put it into words, right? Just telling you, what do? I do vertical stretch by a quarter, then I reflect it in the x-axis, then I move it left 1, and then I move it up 6, and then you can take any point and do that to it, right? It's easy. Without the description, it's hard, right? So you need to be able to take an equation, a transformed equation, and put it into words. Okay. Ready to move? A parabola is given by the equation y equals 2, x minus 3 quantity squared minus 7. The vertex is 3, negative 7. Algebraically show the parabola passes through. How are we going to algebraically show the parabola passes through that point? So we're going to plug in what? X is 6 and y is 11, right? So here's where we're starting. I'm just going to rewrite this. Y is equal to 2, x minus 3 squared minus 7. I always like rewriting stuff that's kind of obvious just because then I've got a full solution. If you just start on the next line, which is 11 equals blah, blah, then it can, you might get yourself confused if you're looking back at it. It's like, wait a sec, where is this, where's it? There's the original, right? I know it's at the top of the page, but okay, look, I'm starting here. Now look what I'm doing, right? So now it's obvious that I have replaced the y with an 11 and that I replaced the x with a 6, right? That's obvious. Just writing this line here requires me or anybody else looking at it to kind of say, wait a sec, what's the original? Oh, right, there it is up there, right? So take that away from yourself, right? It removes confusion. Even on a test, do this, then do this, now do this. Okay, you, do this. So if a point lies on a parabola, then it satisfies the equation. And satisfies means it makes it true. And 11 equals 11 is true. And if you got like 11 equals 13, if we were trying some point that wasn't on the equation, like 511, you would end up with 11 equals 5 squared 4, negative 3 or something, I don't know. But you'd end up with a statement which says, wait a sec, that's not true. At which point you say, well then the point isn't on the parabola since I have generated a false statement. Okay. Use symmetry to determine the coordinates of another point on the parabola. So we got 6, 11. So what's the other point? Now it says to determine, and determine means what? Show your work. Okay, so where was the vertex? 3, negative 7. 3, negative 7. And what was the point we were given? 6, 11. And so the other point is? So how far did you go this way? 3. So how far are you going to go this way?
3.
So where are you? 0, 11. Okay. X equals 3. So by symmetry, if I'm 3 units to the right of the axis of symmetry and I've gone 11 units high, then if I go 3 units to the left of the axis of symmetry, I must also be 11 units high. Right? Make sense?
Could you have also done?
No. I mean, you could have plugged something else in, but this is the easiest one, right? It's, hey, I know 611 is on there, and I know that by symmetry, these points will lie on a horizontal line. And, I didn't draw it great, but, if we make the dot big enough. And it's just a sketch anyway. So, is that it?
That counts as showing work.
That counts as show your work, right? Because there's stuff there.
Okay.